Hello everyone, I am Ajay Singh Naruka here with the solution of our previous video regarding transmission line modeling and performance. Okay, today we will talk about the solution of that questions. I think you have attempted that questions. If you have any problem regarding any solution, then you can comment in your comment session. Okay, in comment you can also say that how many questions you have attempted and how many are right and wrong, so that I can reply you regarding according to that you will how many marks will get in the transmission line modeling and performance. Okay, let's start with the transmission line parameter solution, regarding modeling and performance solution. Okay, this is the transmission line modeling and performance. 30 minutes will be provided to for the 10 questions. Here is the first question solution, that is the per unit system. So in this question I have talked that these are the old datas, these all are the old datas, and the new datas are these one. As I have talked that here you have to take V base different, here V base different. For the transformer the primary and secondary rated voltage will be the different, here the V base will be different. Here the V base will be how much? Transformer rating 220, as it is given. For the 50 ohm line you have to take 220 kilovolt, so it is 220 kilovolt. Okay, here according to 220 here you have to take 33, and here also 11 kV, this one side. Okay, these are the old datas and these are the new datas. These are the V base and this is the S base new, that is 100 MVA. For this one the calculation will be different, as I have talked about it in the solution, that Z per unit is equals to Z actual upon Z base, that is VB square upon S base. Let's talk about it. This one. This is the formula. Per unit new is equals to per unit old into S base new upon S base old into V base old upon V base new whole square. These are the new values of all of that one. And this is the final XL, as its value is not given in per unit, its value is given in ohm. Percentage also in per unit, as you know, I think 20% is 0.2 pu. This is given in the ohms, so you have to use Z actual upon VB square upon S base formula. So this is the formula regarding the per unit. Now you can solve any stability, any fault question, any transmission line modeling and performance question. The first question of the transmission line modeling and performance is this one. Here these are the ABCD parameters, as I have talked about it. Then the formula of the S will be what? Vs Vr upon B angle beta minus dial minus A Vr square upon B angle beta minus alpha. Okay, ABCD parameters are given and Vs and Vr are also given. Here these are the sending and receiving end voltage are maintained at 220 kilovolt. So the Vs and Vr are equal, both are flowing for, this is the P are given, and for the power factor I have talked about it that you need to calculate the QR. Okay, let's talk about it here. Here is the solution. P is equals to Vs Vr upon B sin del. From where this question, this formula is derived? From that one you have to put alpha equal to 0, this one, alpha equal to 0. Okay, so this is the formula will be there. And for the beta is equals to 90 degree, for the beta is equals to 90 degree, first of all you need to understand that this is the lossless line. For the lossless line the formula is simply P is equals to Vs Vr upon B sin del. Okay, here you can also see here, because as it is 90 degree, look at here, the formula of P is equals to how much? Vs Vr upon B. Okay, here it is cos beta minus del. It is beta is 90 degree, so cos 90 minus del is how much? Sin del. So what will be it? This one, it will be Vr sin del minus A Vr square upon B, this one, A Vr square upon B. And what is here? Cos beta minus alpha, alpha is 0, but cos minus 90 is what? It is 0, so it will be absent here, this one, A Vr square. Okay, so here it is only the formula Vs Vr upon B sin del. Okay, look at here, This is the formula of P. P is given, so you can calculate del here, as I have talked about it, that in the every modeling and performance question, first condition is generally given to calculate the value of del. When you calculate the value of del, then you can put this del in the formula of Q. Okay, when you will put in the formula of Q, then you will calculate the value of Q, and when you will calculate the value of Q, then you can calculate the power factor by the formula of P by S. S is equals to under root of P square plus Q square simply. As Q is negative, so the power factor will be leading power factor. This is the leading power factor. I think you have solved this question because this is very simple question. Okay, the next question is this one. Again for the unity power factor load, first of all you need to write down the formula for the Q. Okay, this is the formula of Q. Q will be 0 at the unity power factor. This is the overall formula as I have talked earlier. When you will put this value equal to the Q equal to 0, then from here you will calculate the value of del as I have talked about it. Then the first condition is generally given to calculate the value of del. When you calculate the del, then you just put down the value of del in the formula of next, that is P, and when you will calculate the P, as Q is 0, P when you will calculate, then you have asked in question per phase power. This is the total power, so you have to divide it by the 3. This is the per phase power. Next question, again the same. Okay, here line capacitance is neglected. It means in line capacitance neglected always in short transmission lines. So here you need to apply the formulas of short transmission line, steady state stability limit, as I have talked that here no need to talk about the Q, only talk about the P. P's maximum value steady state. So first of all you need to calculate the overall impedance Z. R and L is given, C is neglected, so no need to use C. Only series impedance Z is equals to R plus J omega L, this one. And these parameters are given in per kilometer, so you need to multiply by the kilometers, that is 500. When you will calculate Z, you can calculate A and B. For the short transmission line, you have the formula A equal to D equal to 1 and B equal to Z. A equal to 1 and B is equals to Z. When you calculate A and B, then you can apply the formula of P. In P formula, for the steady state stability, P should be maximum, and for the P should be maximum, you need to memorize this, that here cos beta minus del should be 1, and for this should be 1, it should be cos 0. Here for the 0 degree angle, beta should be equal to del. So this is the condition for the steady state stability limit, or you can say that this is the condition for P max. This one P max, this one P max. Here from here you will calculate the value of P max. When you will put down the beta is equals to del, then this will be the 1, so it is Vs VR upon B. B equal to what? Z, so B equal to Z, and this formula will be here, this one. Here alpha is given as 0, beta is what? Theta, this one 76.4 degree, this one. So from here you will calculate the P max, that is a steady state stability limit. Steady state stability limit is what? The maximum power of P. Okay, the next one, this one. Next question, again for the maximum power, steady state stability limit. For the maximum power, again beta is equals to what? Del, and in this question you have to differentiate the P max with respect to R, because you need to calculate the value of the R, so its differentiation should be 0. For the maximum power, for the maxima or minima according to the mathematics, you need to calculate the first differentiation should be equal to 0, and the second differentiation, as we know, that this should be negative for the maximum value, and for the minimum this is positive, but we have no need to check about it. We will do what here? The first differentiation will be 0. Here is the solution, this one. I think you have solved it. This is PR. PR's formula for the maximum power, theta is equals to that, as I have talked about it. This is the PR max. Here what is cos theta? Cos theta is equals to R by Z. What is R by Z? Cos theta is equals to R by Z. Z is given what in question? R plus J, R plus J2, R plus J root 2. So it is R square plus root 2 square is 2. It is Z is equals to under root of real part square plus imaginary part square. This cos theta formula, this one formula will be put it here. When you will put it here, then it will be overall dependent on the R. Now for the maximum value, we will differentiate the PR with respect to R, and when you will differentiate it with respect to R, then the R value will get is equals to root 2 by 3. So the first question was according to the per unit value, regarding the per unit value. Okay, that will work in all chapters like our transmission line, stability, fault analysis, everyone. After that, we have talked about the formulas of P and Q. In modeling and performance, P and Q formulas are here. P, R, Q, R, P, S, Q, S. PS and QS are only calculated when the when in question sending and generator 1 or generator 2 power factor have been asked, or Q losses has been asked. Simply this one, look at here. The first question was per unit system. Okay, the next question is regarding again P and Q. This is the P and Q, same formulas. Again P and Q, this is the P and Q. Again what? Maximum power steady state stability limit, as we have talked about it, and this is again maximum power. Next we will combine PS, QS, PR, QR. This is the next question, this one. As we have talked about it in the questions video, station loads are equalized. First of all, you need to calculate the total station load. Load means only P. Here it is 10, here it is 20, so the overall is 30. 30 will be equalized by 15 and 15, so from here it will be 15, and from here also it will be 15. This is P. Now we need to calculate Q. What? How we will calculate now Q? First of all, tell me, from here 15 to 10 is here, so how much will be the here? 5. Here it is the lossless line, so 5 will be here, so 5 here, 15 is here, so it will be total 20. It is equalized. Now listen carefully. What is PS? PS is given as 5, so you have to talk about it. PS formula is VS VR upon X sin del. As I have talked about it, whenever the first formula is applied is only to calculate the value of del. You will calculate del from here. Next you will calculate what? QS. Formulas are these one, this one, this one. First of all, equalized 15 15. Now first of all, PS for the del calculation, this is del. Okay, this is del. Okay, next QS formula is V1 square, or V1 is Vs and V2 is VR. Okay, it is V1 square upon X minus V1 V2 upon X cos del. From here you will calculate QS, as I have talked about it, that what? When you will calculate what? QS, that is QS from here, then 5 is here, QS and QS, this one. From here QS, it is 5, both are, when both are added, then the total Q is from generator Z1, and here we need to calculate the power station 1 Q. So power factor means here P is what? 15, and Q, as we have calculated this one, what? From QS. So when we add both of these one, total generation from generator 1, 10 plus 5, that is 15 was total, and Q5, that was given to the load, and this one will be the QS. When both are added, then this will be the total Q. This is total P and this is total Q. So now you can calculate the power factor of station 1. Again listen very carefully. You can also calculate QR from here. When you will calculate QR, then you can also calculate the power factor of station 2 also. How it will be? When you will calculate QR from here, what will be the formula of QR? V1 V2 upon X cos del minus V2 square upon X. From this formula, this will be minus 1.34, as it is generally QR is equals to minus QS, simply, when it is the lossless line. Okay, now this is QR and QS is given minus 1. So you can calculate the Q loss in this one also. In inductor there will be Q loss, and in resistor there will be P loss. For the P loss you have to calculate PS minus PR, and for the Q loss you have to calculate from here QS. So it is QS minus QR, QS minus QR. You can see here that QS is 1.34 and QR is minus 1.34. So the total answer is 2.68. This is the Q loss. This can also be asked, because in previous last year question, this question has been asked regarding to the Q loss. You can also calculate the power factor of station 2. as same as the station of 1, you need to calculate as you have calculated QR. Regarding QR is coming, okay, from G2 it is QG2 is coming, this is total Q coming and the outgoing is 10. So from here you can calculate QZ2 because QR you have calculated, 10 is given, from here you can calculate the QG2. PG1 as it is given 15 equalized load, and QG2 when you will calculate from here, then PG1 then PG2 and QG2 will provide you the power factor of station 2. So when you will calculate for the PS and QS also, as we have talked about it, we have seen that PR and QR is enough to calculate, but PS and QS are calculated when two things can be asked for the PS and QS, the power factor of the stations or Q loss can be asked. For that you have to calculate QS first of all and PS also. PS is generally equalized load is given. Okay, so the same question is the next question, this one. Lagging power factor is why? Because Q is positive, and if it will have the negative value, then it will be leading power factor. Same question here, two loads, two bus bar, 40 megawatt. From here you can calculate SD1 PD1 plus JQD1 plus is means lagging power factor. Here it is next 20 megawatt 0.6 lagging power factor. So from here you can calculate PD2 plus JQD2 because this is the lagging power factor, so it will contain the positive value of Q. As D1 as D2 calculated, now station loads are equalized. So 40 megawatt plus 20 megawatt total 60, total equalized means from here also 30 and from here also 30. Remember this thing, that what is the mean of load equalization? Only P equalization, not Q equalization. So you have calculated the P, but you need to calculate Q here because here the asked question is power factor of station 1, same as the previous question. Power factor of station 1, power factor of station 2 or Q loss, you can be asked, this question can be asked. Okay, here reactance is 6 ohm is given. Okay, so it is 6 ohm. Okay, this one X is 6 ohm. Okay, 6 ohm. So first of all PS is determined for the calculation of del, as we have talked about it. The first condition is always given to calculate the del. Okay, same loads are equalized, and from here 30 it is 40, so from here it is minus 10. When PS is minus 10, don't be hesitated from this one. Okay, if it is minus, then del will be negative. Simply the practical thing is that PS is not flowing in this direction, P is flowing in this direction, but draw as same as the question we have always draw. If it will be negative, then del will be negative, the final answer will be same, don't worry about it. QS, del will be negative, cos minus theta will be cos theta, so QS will be calculated from here. So now it is total SD1 and it is total PS and JQS. This is the overall generation from power station 1. When you will calculate P and Q, then you can apply the formula of power factor, that is P by S or Q by P tan inverse cos. I think you can understand this one. Okay, the next question, as we have talked about the overhead transmission line completely, PS, QS, PR, QR, P loss, Q loss, and the formulas of PR and QR regarding the ABCD parameter also, and for the lossless line also. Remember the PS, QS, PR, QR, all formula should be clear to you. PS and QS, sending end powers formulas are only used for the station power factor. Station means generating stations power factor used, and loss, that is the Q loss and P loss. P loss is generally 0 when the lossy line, then you can refer the Nagraj Kothari an example with the lossless line. With the lossless line the calculation is too complicated, so never ask in the gate question. Simply lossless line always asked for the PS and QS questions. Okay, so you need to calculate only Q loss. Q loss, power factor of station 1, power factor of station 2. Simple. Okay, next we will go for the, after the overhead line we will go for the underground cable. As I have talked about it, for the economic overall diameter, The condition is capital R upon small r equal to E. And the dielectric strength formula is what? Its formula is Z max is equals to V upon R ln capital R upon small r. From here, when you will put it here, E here, then you will calculate R from here, because G max and V are given in the question. When R will be given, R will be calculated, then R, just put it here, R multiply by E, then you will calculate capital R, and for the overall diameter you will multiply capital R by the 2. The cable is somewhat like this one. This is the cable with R radius, and this is the outer sheet. Its potential is always 0. This is the outer sheet. This is the overall overall radius, that is capital R. This is the conductor and this is the metallic sheet. Okay, this is the question. For the economic size, capital R upon small r should be equal to E. G max, its formula, capital R upon small r equal to E. So from here you can calculate the R, and with capital R upon small r equal to E, then you can calculate the capital R, that is RE, and you will calculate the capital D by multiplying it by the 2, 7.07 centimeter. Okay, the next question again with the cable. Cable means again with the grading system. Grading system is used to minimize the stress in the cable. Stress at what point? Listen, suppose this is our cable. Okay, 1 minute. Here is the radius R. Here is the cable, capital R. As we know that metallic sheet has the potential how much? Metallic sheet has the potential of 0 volt. Okay, here suppose this is the 11 kV cable. So its surface potential is 11 kV. So it is 11 kV, it is 0. So in middle it is insulation. So due to this potential difference 11 minus 0, due to this potential difference the charge will try to flow from high potential to low potential. Due to this potential difference there will be charge flow, and due to the charge flow there will be an electric field here. E is equals to how much? It is Q upon 2 pi epsilon x, this one. Due to this electric field, the charge can be flow from high potential low potential, and if charge will flow through the insulator, then the insulator will get damaged. So here insulator can damage due to this electric field. So this electric field is named as electrostatic stress. And in cable, the maximum cost of cable is due to the insulation cost. So we need to save the insulation from this electrostatic stress, and to save the cable insulation from electrostatic stress, that is we need to minimize this electrostatic stress in insulation. This electrostatic stress also have another problem, that this will distribute in this cable non-uniformly. Means here we can say that this one, this one, this one, when you will draw it, then this will be like this one, stress will be this one. The maximum stress will occur at the this one, sorry, here it will be 0. Look at this one, this one. In internal side the stress will be 0 because charge will be 0. At the surface the stress will be max, that is Z max. E is denoted by the potential gradient also, and this is the stress diagram, this is the Z minimum. So here potential difference or stress distribution is also non-uniform. So we need to minimize this potential stress from here. So what we need to do for this one? To minimize this G max, we need to use grading. How many types of grading in cable are used? Remember this thing. For the gate questions, for the gate examination, 2 types of gradings are important. First of all, capacitance grading, and the second one intersheet grading. Actually electric field distribution is in gate syllabus. Electric field distribution in overhead and in underground cable. In underground cable never ask this question of the grading. So this is important because IIT Delhi is preparing for the GATE 2020 question paper. So this will be the toughest paper, as we know that IIT Delhi will make the toughest paper, as it has made it in 2012. That is the toughest paper, and this paper and that paper will have the minimum cutoff, as we know that this one. Okay, okay. So listen about it. We need to use grading system for this one. For grading, two types of grading we generally used was capacitance grading and intersheet grading. Here the question is regarding the capacitance grading. Capacitance grading, this one, R, capital R. For the capacitance grading, we have divided the total insulation in the two parts, that is epsilon 1 and epsilon 2. Two different materials are used for the dielectric epsilon 1 and epsilon 2 at the different distance R1 and R. The first formula we will use for this solution is, this is Q. What it is? It is Q. This one. From where this formula has derived? As we know that E is equals to potential gradient is equals to Q upon 2 pi epsilon x. So from here we can say that Q is equals to what? 2 pi epsilon x multiplied by G. This is the first, so it is epsilon 1, this is small r, and this is Z1. This is epsilon 1, this is after r, and its stress is Z1. When the charge will flow in this, then the charge will go in this thickness also. So the same charge will flow in 2 pi, not epsilon 1, it is epsilon 2. It is not r, it is r1. It is not Z1, it is Z2. Here when you will cut out the 2 pi, then it is epsilon 1 r G1 is equals to epsilon 2 r1 G2. This formula is here. In the question, r is given, you need to calculate r1 from here. When you will calculate then this one, then you need to use the formula of voltage. From where this formula has derived? Look at here. As we know that G max, in the previous question as we have, G max is equals to, this is capital R upon small r. This is the formula of stress. From here we can calculate the formula of V. What is the formula of V from here? It is Z, it is R, it is ln, in the bracket, this is the multiplied here, R, and after R, in previous question directly capital R, but here is after small r, here it is small r1. So we need to use small r1. This is the first layer stress, that is Z1. First layer voltage, that is V1, and the second layer is in series, so plus V2 we need to use. So plus for the V2, here it is Z2, and this is not after R, this is R1, and it is ln, this is R1, as these are the same RR. It is up to the R1, this is up to the R, this one. From here, you can calculate the V. As these are the maximum stresses, so we will also provide the peak value or maximum value. But here we need to calculate the RMS value in the question, so we need to divide it by the root 2. So this is what capacitance grading. We need to use two formulas, V formula and Q formula. Okay. Next, the last question solution here. This is the last question in the previous sliding also. In the previous, as we have talked about the transmission line parameter also. In previous, again, first of all, remember this is at no load condition. No load condition, VR no load, get the formula of Vs by A. So from here, what we can calculate? The formula of A. In the previous question also we calculate the formula of F, but for in the previous video, for the transmission line parameter we have used long line. So for the long line we have used the formula of K is equals to cos beta L, but here this formula is never used. Here velocity of travelling wave is given. So what we will use here, first of all we think about it, that here length of the line has been asked. From here we will calculate the value of A. What? Vs upon VR no load. What is Vs? 220. And what is VR no load? It is 240. A's formula is, here it is the medium transmission, so it will be 1 minus omega square L square upon 2 Vc square, because as this formula will have contained the velocity of travelling wave. 1 minus omega square L square upon 2 Vc square is equals to 220 upon 240, and from here you can calculate the value of L because Vc is given. From where this formula has been derived? So listen very carefully. Listen very carefully. For the formula of A, this one, sorry, A. The actual formula is 1 plus yz by 2. Here it is the lossless line. For the lossless line, y is only j omega c, and this is multiplied by L. Total shunt admittance, and the series impedance will be j omega L, that is will be multiplied by the length, that is divided by 2. It is j and j, that is minus 1. J square is minus 1, so it will be 1 minus omega square L square upon 2. It is LC. Capital L and capital C, as we know that velocity of propagation is 1 upon under root LC. So from here, this LC can be replaced by 1 upon VC square. So from here, it will be VC square. So this is the formula of A, as we have calculated the A from Vs upon VR, no load, VR, no load. So from here we can calculate the value of A. This is the solution. VR no load is equals to Vs by S. So from here we can calculate the value of A. The formula of A is this one. So from here we can calculate the value of L. Okay. So just put your comment that how many questions you have solved, and tell me that how many questions have you solved, and that are which how many are correct and how many are wrong. So I can reply according to that how will you get, how many marks will you get in the GATE examination, and how your preparations is going on. Okay, thank you.